All right, let's take a look at examples to illustrate the use of product rule as well as quotient rule. So you can see A requires you to use your product rule. Product rule says differentiate uv actually is u dv dx plus v du dx. All right, to put in layman terms, sometimes people remember it, but you keep this, you differentiate this, and then keep this, and then do it the other way around plus the other way around. So very quickly, I will show you. Essentially, you differentiate sine x first, and then you keep x, and differentiate x, and then you keep sine x. Some people remember it this way. Personally, I do it like that. Then you can further simplify, differentiate sine x, you get a cosine x. Differentiate x, you get 1. So therefore, that's the final answer. Quite simple. Now let's take a look at B. Using quotient rule. The first method I'm going to use is quotient rule. Okay, I'm not going to belabor quotient rule. You can refer to your notes there on, I'm quite sure quotient rule is stated there in one of the results. In your first line, what you do is you differentiate the numerator here. Correct? Differentiate the numerator, then multiply by the denominator. Let's not forget it's a minus. Okay, and then differentiate the denominator multiplied by the numerator. So let's carry on and see what happens after that. So you will get a 1 minus x squared multiplied by a 3x squared minus x cubed multiplied by minus 2x divided by 1 minus x squared cubed. Now you do realize that actually you can factorize your x squared out. There's a common factor of x squared. So I can factorize my x squared. What remains is 3 minus 3x squared plus, yes, plus a 2x squared. 1 minus x squared square. Right? Because when I factorize x squared out of here, I have an x here, I have a 2x here, I have a plus 2x squared here from here. So I think we further simplify, you get x squared 3 minus x squared. I think this is the best we can get, which is actually what you see in your notes. Right. Of course, there is an alternative way. In this way, we use quotient rule. There's an alternative way to solve question B. I can use product rule. You can see here, I'm using product rule. In order for me to use product rule, I have to rewrite it like that. That means it is x cubed multiplied by 1 minus x squared to the power of minus 1. So now it becomes a product of two expressions instead of quotient. So I'm going to just write the first line here. All right, first line here. What do? You differentiate this one first, differentiate this second expression first, and then multiply by x cubed. So this is what I'm going to write. I say again, you differentiate this expression first, and then times your u. All right, and then this is your dv dx, and then this is your du dx, this is your v. So let's carry on. What will we get here? All right, what will we get here? You differentiate, you will get x cubed, and then you have a minus 1 minus x squared to the power of minus 2. Let us not forget chain rule. You have to differentiate one more time, you get minus 2x. Yes, plus you have your 1 minus x squared to the power of minus 1 multiplied by 3x squared. Alright, so that's it. That's as far as differentiation is concerned. We do want to simplify it further. Yes, you can see actually from here. Let me use a different color now. Yes, you can see from here that I have this expression and this expression. I want to make a common denominator called 1 minus x squared square. So the first term is not a problem. The first term already quite nicely done, in that you can see that it is a 2x4. Correct? Yes. X cubed times minus 1 times minus 2x. This one you have to multiply numerator and denominator by 1 minus x squared, because the denominator 1 minus x squared square. So therefore it is a plus 3x squared 1 minus x squared. Simplify it. Similarly, I'm quite sure you will get the same answer, x squared 3 minus x squared over 1 minus x squared square. From here to here, there's some simplification, but I don't think it's terribly difficult. You can do it on your own. All right, that's that. Thank you.